Welcome to Module D, problem number 1 on page 753. We're talking about Paul Harold's styling shop. And we have a waiting line problem. And we need to answer the questions A through E. One of the things you may quite like about the software for this particular chapter is you only need to enter 2 numbers. So in this particular case, it's a single channel because there's just one stylist, and they don't go through multiple stages. What I mean by that is Paul does all of the styling for performing the haircuts. So we go to our Excel OM software. We go down to Module D, and we go Single Servo Model. In this particular case, I'm also going to include the probabilities. And you should select that. It'll include the cumulative probabilities. And we go OK. So in this particular case, the arrival rate. Now you have to be careful with the arrival rates and the which is the demand, and the supply rates, which is the capacity. You have to make sure they're in the same time context, which they are in this case. So customers arrive at a rate of 3 and per hour, and Paul can do 5 haircuts in an hour. And that's all you need to enter. But now you need to interpret the results in the results table. Find the average number of customers waiting for haircuts. So in this particular case, this is the answer for A. Average number of customers waiting, which is the number of customers in the queue. Remember, there's the waiting portion, there's the service portion, and then there's the system. So the waiting plus the queue, the waiting is the queue. The waiting / queue plus the service time equals the total time. So in this particular case, on average, there is 0.9 of a customer sitting in a chair waiting to get their haircut. Find the average number of customers in the shop. That would be the number of customers waiting plus the number of customers being served. So there's number of customers on average in the system is 1.5. So you don't even have to do any calculations, you just have to know how to read and interpret it. Find the average time the customer waits until his or her turn. So the average time in the queue is 0.3, but that is in hours. To convert it to minutes, you go equals, and you of course multiply by 60. And then this answer will be in minutes. And most of the time, you'll want your answer in minutes. So be careful when you're doing your study plans and your assignments and quizzes. That does it ask, when it asks for the waiting time, does it want it in hours, or in this case, minutes? And I'm pretty sure in your cases, it's going to ask 40 minutes. We don't normally quote things as, so how long are we going to have to be in the waiting line? 0.3 of an hour. All right, 18 minutes is the correct answer. So just be careful with that. Find the average time the customer is in the shop. Once again, this is 0.5 hours. And to convert it into minutes, this multiplied by 60. And once again, you get minutes. So about half an hour by the time you arrive to the time you leave. And businesses need to set standards. I'm sure you've all gone to certain places because they're really fast. They set standards as to how quickly they can serve a customer, how many customers stand in line. When I worked at London Drugs, their standard was 1 customer being served and 2 standing in line. That was the max. If you listen to the lecture notes, you probably have heard that already. So businesses need to set standards on this. Is half an hour to go and get your haircut a reasonable length of time? For certain places, that would be actually short. Say some salons where and a lot of times they do more than just cutting your hair. But you would have to see, are your customers pleased with the fact that they spent half an hour? Remember, they spent 18 minutes sitting there and 12 minutes getting service. So you have to be careful to see if your customers are satisfied with that. Find the percentage of time that Paul is busy. So there's two ways to do this. So I'll just go back a second. So this is the answer for C. This is the answer for D, if I didn't make that clear. And server utilization rate is 60%. So Paul, in this particular case, is doing haircuts 60% of the time. And you can see the probability the system is empty, in other words, there's nobody in the shop, is 40%. So what that also does, by the way, you say, well, what is to do with the 40%? Well, they would order supplies, clean up the hair clippings, tidy up the shop, things along this line. Answer phone calls, check the website for appointments, etc. So there's other things besides just cutting hair that you need to pay attention to if you are Paul in this case. So that's the end of the presentation for this particular problem.